What's up, game developers? Couch Ferret here, and today we'll design our first level with the help of grids. We'll also make our sprites render in a correct order, so the ones that are closer to us will render in front. This will give our game a nice 3D effect. If it sounds fun, then stay with me and consider subscribing with the bell icon so you won't miss any future videos of this game. Cool, let's begin! Before we start building our world, we need to import the new sprite we've created in the last episode. Let's use a new folder for the level's elements and drag and drop the sprite into it. We need to set the usual parameters on the sprite's inspector page, like the sprite mode, filter mode, and compression. Hit apply so we can open up the sprite editor to slice it. There's a clever little button in the sprite editor which switches the sprite's visualization between colored or alpha only. If we toggle it to alpha only, then it's easy to see where the individual elements are. Let's slice them one by one. I disable the current archer to not bother us while I'm explaining today's task. Okay, let's drag a pillar and an archer into the scene so I can demonstrate our problem. The thing is that it doesn't matter how I move the archer around the pillar, he always stays behind the pillar. He should be rendered in front of the pillar when he is closer to the bottom of the screen. This would give us a three-dimensional feeling in the game. But currently, our game is flat. We can tell Unity which sprite it should render on top by giving the sprites a sorting order value. If I crank the number up, he appears in front of the pillar, which makes it look more like we have a 3D space. However, now he always stays on top, no matter how far I move him. We could dynamically change the sorting order for each sprite based on their Y positions, but that's too much work. Unity has a pretty cool and somewhat hidden feature, which handles the whole sorting for us without writing a single line of code. By default, Unity sorts the sprites based on their Z position, which is the direction into the screen. But we can change that to sort it based on Y positions if we change the sorting axis from the direction into to the direction up. We can do that if we go to Edit, Project Settings, Graphics, and set Transparency Sort Mode to Custom Axis, so we can override the axis below to the up direction. Now if we grab the archer and move it around the pillar, it will appear behind or in front of the pillar depending on his position. How cool is that? It starts to look like our game has a three-dimensional space, but it feels somewhat imprecise. The sorting flips earlier than it should. The archer's position is behind the pillar from our perspective, but the sorting makes it appear in front of the pillar. The source of this problem is that Unity uses the sprite's center point to sort them, which doesn't give us the desired 3D feel. We need to somehow tell Unity to sort them based on where the objects touch the ground. We can do this multiple ways. The first one is that we can change the sprite's sprite sort point parameter from center to pivot, so Unity uses the pivot point defined in the sprite editor to sort them. Then we can define a custom pivot point for each of the sprites in the sprite editor. Let's move the pillar's pivot to the middle point where our pillar would touch the ground if it was a 3D object. Hit apply and do the same for the archer as well. For the purpose of this demonstration, it's enough to change only one slice. If we test it now, it should be more precise than it was. Yeah, it looks fine. The colliders will help it a bit, so the archer won't be able to walk too close to the pillar, but we will see that in the next episode. This solution is fine, but I have concerns with manually setting all the pivot points for the animation sprite sheet. So I'll revert these changes and show you a better solution. The second way, and in my opinion the better way, is to give custom pivot points to Unity with sorting group components. Let me show you why I'm explaining. But first, let's change the snapping tool's parameters to work on a pixel basis. If we go to the Edit, Snap Settings and change the Move X and Move Y to 0.005, then we can move the objects by half a pixel by holding down the Command or the Ctrl key. This will help us position the sprites and their pivots precisely. Let's zero out the sprite's position, create a new empty game object, and name it Archer. Drag and drop the sprite into this new game object so it becomes its child object. Zero out both of their positions. The parent object's position will be the pivot point, so we need to move up the child object relative to the parent. Make sure that it's correct on both axes. To make the parent object into a pivot point, we need to add a sorting group component to it. This will overwrite all of its child objects' sorting information. Quickly do the same to the pillar so we can test it out. See, it's working just like our first solution. Let's create game objects for the horizontal and vertical wall pieces as well. The horizontal one is easy, but the vertical is a bit tricky. However, if we align it with the other pieces, then we can figure out its pivot point. Don't forget to use snapping while aligning them together. There's one last thing we need to fix before we are done with the whole sorting thing. We have to change the original Archer so its pivot is also at the bottom of the sprites. Let's select the original Archer game object, enable it, and delete the dummy one. We need to reset its position, create a new empty game object to act as a pivot, and move it down to the correct position. Now we can move the two sprites into it. And don't forget to add a sorting group component as well. Let's run the game and test it out. It works like a charm, and it was quick and easy. But when we move and shoot at the same time, we got an error. Let's find out why. Double-clicking the error message in the console window will lead us to the point where the error happens in the code. Okay, I see it. We moved the sprites one level deeper in the hierarchy, so the sync state machine behavior can't find the player controller script to access the bottom animator. We need to insert an extra dot parent to fix this. It works perfectly. We can move forward to the level design part of this video. We can make our lives so much easier if we use grids to position the level's elements. Unity has a component called grid which will force its every child object into a given grid. This will make every placement perfectly precise. Let's create a new empty game object and name it grid. To make it act as a real grid, we have to add a grid component into it. Let's change its cell size to 0.1 by 0.04 so it matches our perspective from the last episode. I've also changed the tool handle's position from center to pivot. Now, if we make the pillar game object into a child of the grid object, then it moves according to the grid. The smallest amount we can move something in a grid is 1/2 of the cell's size. Let's drag the horizontal wall game object into the grid as well. It's not bad, but we want the wall to be 1 pixel up in the y-axis. Because the grid forces its child object's position to be on the grid, it doesn't let us move it up just 1 pixel. We have to do a similar trick we did earlier today, but now we will define a new pivot point for positioning and not for the sorting. We can do this by creating a new level of game objects in our elements. Let's create a new empty game object outside the grid. Let's name it horizontal wall, rename the previous horizontal wall to sprites, and move it under the new game object. We need to reset both of their positions and move it up by 1 pixel so it fits the grid just how we wanted. If we move this new wall into the grid, we can test if we've done it correctly. Now it has a new positional pivot point. We need to do the same thing to the vertical wall as well, which is a bit trickier because its pivot is way down compared to the actual sprite. I quickly tinker with these new positional pivot points, so every element fits on the grid in a way that their pivot point is on the grid's line and not in the middle of the cell. Now we only need to create prefabs out of them and they are ready to populate our first level. Let's drag all of them into the prefabs folder. And here comes the most fun part of today's video, the level creation. Let's build a few walls to make our first level. I want to make some kind of arena here. We can quickly build new walls by duplicating existing ones with Command D or Ctrl D on Windows. As a final touch, I'm adding some grass and flowers as simple sprites. I'm just dragging them into the scene and then duplicating them in groups, so I won't have to create them one by one. It's starting to look like a real game. Let's take it for a spin. Okay, this is awesome. Can you imagine this with 4 players and monsters all over the place? I can't wait to try out the finished version. That's it for today, folks. Next time, we will modify our walls by adding colliders and rigid bodies to them so the archer won't be able to run through them. We will also upgrade the movement script to a physics-based one with velocity. So be sure to subscribe and leave a thumbs up. If you have any questions about what you have just seen, feel free to ask and I try to answer all of them. See you next time!